Okay, we're starting our notes for 10.2, rational exponents. Now, this tends to be one of the more difficult sections in chapter 10. So you may have to go look at the examples in the textbook as well. Look at, watch these notes a couple of times, especially some of the examples that tend to be a little bit more difficult. And you could always go to YouTube, search rational exponents, and look at examples that they have there too. So here we go. So when we talk about a rational exponent, rational numbers are numbers that can be written as fractions. So really what we're talking about is exponents that are fractions. Okay? Now, what you can do, if you look at the definition, if n is a positive integer greater than 1, so that's our index, so it's going to be 2 or 3 or 4, and the nth root of a is a real number, so in other words, there's not a negative underneath, then a to the 1 over n is the same thing as the nth root of a. So what basically happens is when we're talking about an expression with a rational exponent, we're going to change it into a radical. The bottom of the fraction is going to be the index of the radical. So let's put that into action here. So if I have 25 to the 1/2 power, guess what? That's really the same thing as the square root of 25, which we know is 5. If I have 27 to the 1/3 power, that is exactly the same as the cube root of 27, which we know is 3. Now look at this one, 7x to the 1/3. So first of all, notice that it's only the x that's being raised to the 1/3 power. There are no parentheses around the 7x. So the 7 stays outside of the radical. X to the 1/3 would be rewritten as the cube root of x. And then finally, this one, again, it's a cube root, so it would be the cube root of negative 27y to the 6th, which would be, well, the cube root of negative 27 is negative 3, and the cube root of y to the 6th would be y squared. So when you have exponents that are fractions, you change them to radicals to help you solve. Well, let's look at this next definition. If m and n are positive integers bigger than 1, and m divided by n is a fraction in simplest or reduced form, then as long as a to the m over n is true, that is the same as the nth root of a to the m. So look at just what happened. When I changed this fractional exponent to a radical, the bottom number was the index again, just like it was above, excuse me. And the top number of the fraction is the exponent on what's inside. And then another way you could write that is you could separate that and put the nth root of a in parentheses, and that whole thing is being raised to the m power. All right, so let's see that in action. If I have 8 to the 2/3 power, that is the same thing as the cube root, that goes in the index, of 8 squared. Now I want to show you. You can do this in 2 different ways, and that's what they're talking about here. You can say, okay, that this is the cube root of 8 squared is 64, and the cube root of 64 is 4. That's one way to do it. And in fact, that's using this way. Another way to do it would be to do the radical first. What's the cube root of 8? Well, the cube root of 8 is 2, and then you square that. Well, what's 2 squared? It's 4. So in this first method, you square, or you do whatever is underneath the radical, and then you take the root. In the second method, you root first and then you raise to the exponent. Well, let's see that in this one. So if I change that, it's going to be the cube root of negative 27 to the second power. Well, see, here's a perfect example. I don't know what negative 27 to the second power is. That's just too much work for me. So I'm going to use the second way. I'm going to take the root first. So I'm going to take the cube root of negative 27, that's negative 3, and then I'm going to square that to get my 9. And that's all you have to do. How about this one? Well, let's change it to the square root of 1/4 to the third power. I'm going to do the root first. So what's the square root of 1/4? That's 1/2. I need to raise that to the third power. And 1/2 to the third power is 1/8. So there you know how to do your rational exponents. Now let's combine them with a couple of other things. So now look at this. What if that rational exponent is a negative exponent? Let's remind you that negative exponents move things from the top of the fraction to the bottom, or vice versa. If the negative exponent's in the denominator, it moves it to the top. So a to the negative m over n equals 1 over a to the positive m over n. When you move the expression to get rid of the negative exponent, it changes to positive. So let's see what that's going to do here. So the first thing we're going to do is we're going to change this to 1 over 16 to the positive 3/4. Well, then I'm going to change that to 1 over the 4th root of 16 cubed. Remember, the denominator is the index. Well, that's going to be 1 over, and I'm going to do the root first again. What's the 4th root of 16? The 4th root of 16 is 2, and I'm going to raise that to the third power, which is 1 over 8. So you might want to watch that a couple of times. So now remember, at this point, I took the root first. You could cube the 16 and then take the 4th root of that, but I can't do that in my head. That's why I always choose to do the root first. The 4th root of 16 is 2, and then you cube that 2. Well, look at this one. So first of all, notice that the negative 256 is not in parentheses. It's not negative 256 to the negative 3/4 power. It is actually negative 1 times 256 to the negative 3/4 power. It's only the 256 that's being raised to the negative 3/4 power. So when I go ahead and change this negative exponent, I'm going to move this downstairs. That's going to leave a negative 1 at the top over 256 to the positive 3/4 power, which is negative 1 over the 4th root of 256 to the third power, which is going to be negative 1 over, what's the 4th root of 256? Now, this is a hard one. Kind of the way I thought about it is the square root of 256, I know, is 16, and then the square root of that is 4. So that helped me. The 4th root of 256, though, is 4. And then I'm going to raise that to the third power. That's this 3, which becomes negative 1 over 4 cubed is 64. So these are the types of problems that was what I said in the beginning. You might want to kind of look at things a couple of times because there's a lot of little steps involved in here. So up at the top of the next section is just a quick review of your exponent rules. You had these back in, you had some of them in Math 47 if you took that. You had them all in Math 53 if you took that. So just a quick review. So if you're multiplying, you add the exponents. If you're dividing, you subtract the exponents. If you're raising something to a power, you multiply the exponents. You have to remember here, if you're raising a monomial with more than one part, that exponent goes into everything on the inside. So with the A as well as with the B. Even if it's a fraction, the exponent goes with both the top and the bottom. Anything to the 0 power is 1. Hopefully you remember that. And then here we actually just talked about if I have something to a negative power, that's 1 over a to the positive n power. So for these last few examples, we're going to use those rules. So here we go. Notice the bases are the same, so I can go ahead and do this. So what does the exponent rule say I do to the exponents if I'm multiplying? Well, I add them. So this would be b to the 1/2 plus 5/3. Well, you got to add those fractions. You need a common denominator. My common denominator will be 6. So top and bottom of the 1/2 will have to be multiplied by 3. So that's going to be 3/6 plus, here, to make this into a 6, top and bottom have to be multiplied by 2. So that's going to be 10/6. Now that I have a common denominator, I can add my fraction, and I'm going to get b to the 13/6 power. All right, so same as the rules above. It's just now we got to deal with fractions. Fractions happen. All right, well, look at this. Now, again, the bases are the same, the 7s. So this is going to be 7 to the, what does the rule say you do? Well, you subtract the exponents. Remember, the bases don't change. You don't divide the 7s. They stay the same. Well, that would be 7 to the negative 3/3 if I subtract the exponents, which is really 7 to the negative 1. You're never going to want to leave a negative exponent if you are in simplified form. So 7 to the negative 1 is really 1 over 7. Look at this. So now again, look, we are multiplying these two things, so we are going to add the exponents. What's nice here is that I have a common denominator already. So it's y to the negative 9/7 plus 10/7, which would be simply y to the 1/7 power. Now, rule of thumb is if you start off with rational exponents, your answer should end in rational exponents. So in other words, don't change this to the 7th root of y. You started with fractions as exponents, end that same way. Well, look at D here. Hopefully you recognize this is a distribution problem. So we're going to have to multiply z to the 2/3 times z to the 1/3. So that would be z to the 3/3 because I add the exponents, minus z to the, I need to add the exponents, so that's going to be 2/3 plus 7. So I'm just going to do some work here. So this would be z to the 1st minus, okay, this 7 is over a 1. My common denominator is a 3. So top and bottom here have to be multiplied by 3. So that would be z to the 2/3 plus 21/3. So I'm just showing every step of my work. So that would be z minus z to the 23/3 power. And that is going to be as far as you can go here. These aren't like terms, so you can't combine them. So don't be thinking things like that. Okay, so now you always learned that you can only multiply radicals if the radical part underneath the radicals were the same. And that was true if you were leaving them in radical form. It is not true once you know about rational exponents, because we're going to be able to multiply these by using the rational exponent. So take really careful notes here. So I'm going to change these both to using rational exponents. So this would be 3 to the 1/3, because the exponent on the 3 is a 1, and the bottom is the index, times 2 to the 1/2. Okay, the next thing that you're going to do is you are going to find a common denominator and put each of these fractions over that common denominator. So my common denominator would be 6, so this would be 3 to the 2/6 times 2 to the 3/6. Now here's the tricky part. You are going to rewrite this. Now that you have them both with a 6 as a denominator, watch this. You can rewrite this as 3 squared times 2 cubed to the 1/6 power. So look what I did. Remember the exponent rule that said that if I've got something like that, then this, it goes in with the A and you multiply the exponents, and it goes in with the B. You multiply the exponents. I just did that backwards, because if you look at this, that would follow this rule. If I multiply these exponents, this would be 3 to the 2/6 times 2 to the 3/6. I just did it backwards. Well, now look what I have. I have 9 times 8 to the 1/6 power, because 3 squared and 2 cubed. Well, 9 times 8 is 72 to the 1/6 power. And again, remember that rule of thumb I mentioned earlier? If we start with radicals, we should end with radicals. So in this case, we're going to change this to the 6th root of 72. So look how crazy that is. If you multiply the cube root of 3 times the square root of 2, you end up with the 6th root of 72. Again, you might want to go back and watch that a couple of times.